Okay. My name is Eric Stein, and I'm presenting on the heat transfer system, which Chris and I have been working on so far. Brief outline of what I'll be talking about is first we'll look at a system overview of the heat transfer system, then look at some goals and objectives we hope to achieve. After that, we'll look at the previous work we performed, and then the progress we've made since then, and then data and results we've gained, and future challenges we still have to overcome. Here's a rough drawing of what our system will look like when it's completed. There's a glass pipe for water flow, which you can see it's vertically positioned right here. And the water goes in the top of the glass column, and it comes out the bottom. There's 10 temperature sensors to record data within the glass pipe, and they're spread out evenly about 10 inches apart. And to force convection on the system, there are some fans that will be positioned on the outside to force that. Once our system is complete, we hope to achieve first a temperature gradient from the data from the temperature sensors, and with that data, hope to find a heat transfer coefficient. But first, the system needs to be constructed. Previously, we used these temperature sensors, the LM35 temperature sensor, that there's 3 different leads coming out of it. The one on the farthest outside is seen from the manufacturer's schematic, I guess, is for ground. The middle, it would go to the computer, and the outside would be a voltage source that would be between 4 and 20 volts, hopefully. We had to add all these 10 sensors in series, which proved to be difficult since neither of us had ever soldered anything before. So, as you see here, it might look a little rough, but you can see the outside lead goes to this green wire here, which would be for the ground. The middle wire would be this whitish colored wire, which would be for the computer, and the purple on the outside lead would be for voltage. And then we combine them all in series, as you see here, all 10 of them, and it's pretty messy. But since then, we've been able to add all the wires, kind of bunch them together and add them into the glass column as seen here. But we still had to come up with a way to control the flow and to hold the wires in there. So this is what we developed for the bottom of the glass column. This would be going to the glass column here, and then at the bottom it would be to hold the wires in place within the pipe, which you can see here. Just kind of tied it together so it wouldn't come apart. And then this would be a valve to control the water flow as it goes out. So if we need to shut off the water, we can do that if need be. For the top, it's a very similar setup, but again, this goes to the glass column, and then this would be where the water would enter at. And the top, all the wires have to come out the top and be held pretty tightly inside the glass column. So here's the little setup we did at the top so that the wires don't fall down. Well, the system's not constructed yet, so far I don't have any data. But from the manufacturer's side, we found this diagram for the accuracy of the sensor. Ours is the LM35, which you see here and here. And for our sensor, it primarily would be most efficient, most accurate, I guess, within at 25 degrees Celsius, where it's only plus or minus 1 degree Celsius. But as you go out from that point, it becomes more and more inaccurate. Well, we haven't completed building our system yet, so now that we got it on the glass tube, we need to make sure that the sensors are still working, because there's a lot of wear and tear put on them when adding them to the glass column. So those need to be checked to see if they're working. And once we know they're working, they can be connected to the computer to start gathering data. And then the system needs to be set up in a vertical location somewhere in the lab. And once all that's done, hopefully we can add water to the system and then we'll be able to work. Any questions?